Hi everyone, this is Mike for my next video here on my pulse generator, and yeah, things are coming together pretty good. I had one little failure. This base plate didn't turn out the way I wanted. Something happened with the dimensions, so I'm gonna have to redo that. But other than that, performance of this thing is incredible now. As you can see, I am charging this large battery right now, and my charger is putting out about 210 milliamps of charging power. I also have the dial meter here right beside my charge controller, and you can see it is pulsing at about 200 milliamps. Now, what's really cool is the key to this system, because this system doesn't put out amperage. That's the whole problem with the system. So what you have to do is you have to store it up. And I had a couple of people inform me, David Davis, I believe it is, he told me I have to load it up with capacitors. Now, I was fiddling around with a few other capacitors, and I actually have one hooked up. I actually put it in this Tim Hortons cup just for safety, just in case it blows up. It's a 50 volt 4.7 unifarad. Now, since I put that capacitor there with a higher voltage and a low unifarad, it's making my pulses a lot stronger. As you can see, they're a very solid 200 milliamps pulses, and that goes into my charge controller. As you can see, it's full operation. It's actually made for a solar panel, and you can see it's charging. And my battery's already up to 12.71 volts. When I started charging it, it was 12.4. And that's within a matter of like 10 minutes running this. So I'm really impressed by just adding these capacitors to the output. I got one here. That one's a 250 volt, 100 unifarad. So I wasn't getting a strong pulse of 200 milliamps. It was more like 150. But since I added that one that I have in the cup, it's really tiny. It's only 50 volt, 4.7 unifarad. Now my pulses have jumped up quite a bit higher. Now I'm hitting 200, and my meter's telling me I've had it, at one point I had it at 250 milliamps. So I'm charging this big battery, car battery, with this little thing. This thing is a 12 volt, I believe it's 20 hour, 5 amp hours. So that battery's pumping out about 13 volts because I just charged it. I wanted to do a good accurate charge, so it's running at about 13 volts. But look at this. This thing's flying, and it's pulsing really, really strong. Now, I was looking at other chargers that I have called deep cycle chargers, and they're pumping out about 500 milliamps. So my system's putting out about half of what a deep cycle charger can do. So about 210 milliamps. I had it as high as 250, depending on how I tune the motor, if I make it go faster or slower. But yeah, like right now, this battery here is only drawing about 0.48 amps of power at about approximately 13 volts. So right now you can see it's running at about 13 volts. So yeah, I'm making some really cool progress. My charging is increased dramatically. Like you can see my yeah, it's already at 12.77 volts. This thing's pretty well charged. Like this is totally usable now. And I charged this battery. I used another battery to charge this guy up, and I got it at, well, the thing's holding 13 volts. Like it's not even moving. It's staying at 13.1, 13. It's barely moving. And this thing's hovering at about 1,000 RPM. And yeah, so yeah, the trick to this thing is because this thing puts out no amperage, it's putting out pulses, so you have to catch the pulse. And you have to dump it into the capacitor, and then from the capacitor it goes to the solar charger, which controls the voltage going to the battery. So that's how you got to do it. So I added that one extra one in the cup over there. I put it there just in case it blew up. I didn't know what kind of a reaction I was going to get when I hooked it up. But look at my pulses. There are solid 200 milliamps pulses going into the charger. So you can see how the charger is going. You can actually see the numbers now. See, it's almost at 13 volts. See, it's gone up 0.2. See, now I'm at point. So it's gone up almost 0.3 volts in a matter of just a couple of minutes talking here. So yeah, she's charging very, very strongly. So that's pretty much it, guys. So I'm just gonna figure out a better way of wiring up these capacitors. I'm gonna fiddle around with different combinations, see which one works. I'm hoping to get, if I can, 300 milliamps. If I can do that, that'd be great. If I can get 500, even better. But yeah, if I'm hovering about 250 to 300 milliamps of pulse power going into the charge controller, yeah, I'll have very effective charging. Look at this, it's already at 12.8 volts. She's doing really well. So yeah, I'm going to leave it at that. If anybody has any more tips as far as like what combinations of capacitors I should use. From what I was told, higher voltage and very small unifarad. So this one here is 100 unifarad and the other one's only a 4.7 unifarad at 50 volts. So should I use more of these guys or should I use more of these guys, the bigger ones? So yeah, give me some input. Anybody has any bright ideas or whatever they have, let me know. Alright everyone, if you like my video, give me a thumbs up. Don't forget to subscribe at the bottom. And you can also make your comments too at the bottom. Give me a thumbs up, thumbs down, whatever. Alright, hope you subscribe and we'll see you in the next video.